Hello YouTube, welcome back, and I've been given this dimmable light from someone to try and fix. It's fitted with one of these dimmer switches. Currently it doesn't work at all, so you turn it on, turn it up, any brightness, nothing happens. Had a new bulb, apparently the bulb blew, and that's what caused it to fail. So the dimmer switch element inside here is shockingly simple. There's only literally 4 components, and you tapped into the live feed. Underneath there's nothing there, pretty much. But the circuit's very easy to reverse engineer. It's just a normal Triac with a resistor capacitor divider network. I can draw it up and I'll show you what's going on here. So what you have here is very simple. You have this Triac, which is basically like a switch, but it's turned on by a pulse. And once it's got a pulse, it will stay on as long as there's current flowing through it. And of course the input is a sine wave. Every 50 Hertz it changes direction, so every 50 Hertz it will turn off naturally. This is an RC network, and this basically delays the phase angle. So you get a phase angle delay between here, which is adjustable by that resistor, and that changes the time in which that comes on. So if you look at the output, it will be something like this. So your sine wave's coming in like that, but your output will be something like that, changing direction every time. And because you're only supplying power for this amount of time, you're effectively getting a dimming effect on the lamp because power is reduced, if that makes sense. So zooming in on that Triac, you can already see what's wrong with it because the front of it has blown away. So that's been overloaded and shattered. So we just have to change the Triac and it should hopefully work again. Only issue is I don't currently have any Triacs, but I do have some Thyristor, so I have an idea, and I think I've got a room on the board to do it. I think I can use 2 of these as a Triac, and I shall explain why. So this is the device that's in it. It's a Triac, so it will pass current in either direction when a pulse is applied to the gate. So it will pass current in that direction and in that direction. So it will work on both parts of the sine wave. So if you send that in, you get that out. This is the Thyristor. It only passes current in one direction when there's a pulse applied to the gate. Other direction it just blocks. So if you send pulses in, you only get like that. Effectively, you're missing the negative half of the sine wave. But if we got another Thyristor and we put it across this way, this is really equal drawn on camera, like that, and then you join the gates together, then effectively you'll be firing the Thyristor at either part of the sine wave, so you'd end up with that output. I can see if this works, and let's give it a try. So after soldering, this is the result. It's 2 Thyristors back to back, opposite polarities each, to give me effectively a Triac. They fit in the holes actually quite well. So I shall set the pot to midway and turn it on and see what happens. Right, sitting clear of the pending explosion, it's set to about 50%, so it should be on 50% brightness. I shall turn the power on now. Ooh, looks like it's working. Right, I'll put the case on it and then twiddle the knob. Right, so the case is back on, and if I turn it to on and then increase the brightness, hopefully, yay, we have a dimming effect. There you go. So that is now fixed. Well, hope you enjoyed that, and I shall see you next time. Right, ta-ra for now. Bye.